Buckle up, buttercups. Time to talk nuclear energy. Now, nuclear energy is a bit spooky to some, and I understand why. Nuclear reactors, as they are now, are unsafe, inefficient, and produce waste materials that remain harmful for thousands of years. Plus, we only have a finite uranium supply. However, what if I was to tell you that the only reason these negatives exist is because we have barely updated the design of our current reactors since the 1950s? Current light water reactors are not our only option. There are tons of advanced reactor designs out there. One such design is the Thorium-Fueled Molten Salt Breeder Reactor. First off, to even use thorium as a nuclear fuel, it must be paired with a fissile driver fuel like uranium-233. This is because, unlike natural uranium, thorium is not a fissile isotope. Instead, it must be converted into fissile material via neutron absorption and decay. While this is a drawback, conversion of thorium to uranium possesses the unique ability to create more fissile nuclides than it consumes. This means that more uranium is produced than is used, allowing for fuel breeding and, therefore, a continuous, sustainable energy supply. Now, where do molten salt reactors come into play? Unlike other reactors, molten salt reactors have the unique ability to utilize a thorium-uranium fuel cycle to its full potential if using design specifics that allow it to become a molten salt breeder reactor. This is due to molten salt reactors using molten salt instead of solid fuel. Molten salt is a type of liquid fuel that is essentially a homologous nuclear soup of heated fluoride or chloride salt and fissile nuclear fuel. This allows for several benefits that make fuel breeding possible in MSBRs. However, while thorium is typically considered pretty proliferation resistant, the same daughter products that grant thorium proliferation resistance make it unsuitable for fuel breeding, and those products need to be separated out, making MSBRs super vulnerable to nuclear proliferation. Still, not all hope is lost. Not only is there the design of the denatured molten salt reactor, which was made specifically to address proliferation concerns, both MSBRs, their parent design, and thorium fuel cycles in general have a host of other benefits. Of course, the technology is extremely experimental, so a significant amount of development and research must occur before thorium fuel cycles, MSRs, or MSBRs can be considered for commercial use. However, as a result, a litany of specialized MSR designs are being developed, all of which could provide further enhancements to the general MSR design, potentially redefining the future of nuclear energy and global energy consumption.